Welcome everybody to another exciting edition. In this session, we try to help you out with the skills that you might need. And this month in November, we're focusing on analytical skills. Analytical skills could be like soft skills. We don't go into too much technical skills or too technical, because if you go too technical, we might need more hours. So what we do here, we're going to be talking about a technical topic, but I'm going to be presenting it in a soft skill way. So in such a case, if you're non-technical, don't stress about it. If you are technical, this might be a good reminder or helping you to know what your team might not be doing or might be doing quite well. Welcome everybody, both on Zoom. If you're on Zoom, you are able to ask questions. If you're on YouTube, just type in your questions, and then after the session, I'll come back and I'll respond to all of your questions. But my name is Disama Matsietsi. If you don't know me, I've tried this whole passion of mine of being an analyst for a long time, and I got nice requests where people also want to join in. So sometime you might see me, sometime you might see somebody else. Just know that there's a lot of interest in talking about this, and more especially the soft skills. The Excel you can get everywhere on the internet. Everybody on YouTube can teach you Excel, can teach you Power BI, but we are looking for those other little tricks that are differentiating between a novice analyst and an expert analyst. Because what we're trying to do here is trying to take ordinary people and make them into excelling expert analysts. That's what we're trying to do. Hence why we are Inspired Excellence. We're trying to inspire you so that you can be excellent. So before further ado, I'm going to be presenting. I'll try not to be too fast. If I'm too fast, just raise your hand. I can see you on the side here. Raise your hand. Just let me know. Slow down a little bit, and I'll be able to slow down. But I try by all means to not rush, but so that we can understand each other. We'll rather have another session so that we can finish up the whole process. The process, I try to summarize it into 5 steps. I don't go more than 5 things that you must remember. I know sometimes 5 is too much. Maybe sometime we can do it into 3 things that you can remember. But as far as concerned, if it's too fast, just let me know in the comments to say, slow down, go a bit slower. If it's too slow, you can fast forward this if you are rewatching. Then I can be able to go a bit faster. Okay. The topic for today is how can you build a predictive analytics model from scratch? So before we start there, what is predictive analytics? So before we go into hectic stuff to say predictive analytics, I just want to spend 5 to 10 minutes just talking about some of the stuff that happens in real life. Whether it's going to be predictive analytics or not, I just want us to follow the story. So you have a form, you created a form online, people are applying for credit. Let's say, for instance, you work in a bank and people are applying for credit, and you're a normal data analyst. And all along today, you'll get an application and you can process the application to say, this person has got credit scoring bucket 1, you put them there, and the people that the call center people that are looking after bucket 1 can pick up the call, and then they can call. And then another application comes, you can say this one is bucket 2, another one comes bucket 1, another one comes bucket 4. You categorize it quite well because you have the fields. So you have a gender, you'll have income, who you work for, employer, whatever the case is. And then on the rows going down, if you think about it in Excel, on the rows going down is the different applicants coming through. Now, let's say, for instance, now it's December time and everybody wants to apply. So when everybody wants to apply, now you get to a point where you're getting more applications per hour than you can process and say, this one is bucket 1, bucket 2, bucket 3. Let's say hypothetically, you can process 1,000, I mean, you are so efficient, 1,000 classifications an hour. But now, because everybody is so excited about this credit card that they are launching, you're getting 10,000 applications an hour. So now you're thinking to yourself, hold on a second, we're going to be missing out on valuable applications that are coming through because you as a data analyst or normal analyst or senior analyst, you cannot keep up with the rate of applications that are coming through. Now you have to somehow think about ways for the computer to think like you do, to say, oh, this one, if he applied, he has got this horrible credit scoring, should go to bucket 1. This one with a good credit scoring, male, female, where they stay, whatever the case is, bucket 4, bucket 1, bucket 2, bucket 4. But in this case, you don't have that. You have it in Excel, it's manual. And then this is where predictive modeling comes in. You create something that will predict how you as a human will allocate the data itself. Some of the predictive models that you see online on YouTube or whatever, they might be too advanced. Hence why we start with the use case first, to say, what is the issue that we're dealing with? And once you understand the issue that we're dealing with is, we have call center agents queuing up, waiting for you as a data person or a senior analyst to give them to say, call this person. They just did the application, complete this one. They just filled up the leads form. But the problem is the leads form, the number of people that are completing the leads form, it's way faster than you can capture yourself. And that is where you can either hire more people, but it's going to take longer. It might take 3 to 6 months to hire another person. And in this case, maybe you can go and do a model, which is now where you do predictive modeling to say, application comes, it belongs here. Application comes, it belongs there. So without giving so much, that's what we used to do. I worked for a bank for almost 2 decades. That's what scoring does. No analyst in quantitative analyst, nobody sits there from value analytics. Nobody sits there to say, oh, this guy, December he's going to decline. Nobody does that. They build a model, and a model is the one that says you are approved for that credit card or not. You are approved for that home loan or not. And it's only when you query it, then we go into the model and we find out that the model really give you a true decline, which means a false positive or false negatives, or all of those. I tried to cover that one. I mean, on the book, I have this in high level as a chapter under data science, but I thought in this session, it will be good to address one of these questions to say, how do you now start building a predictive model? I think just high level, I'm just giving you a use case. So the step that we follow, if you are going to be building a predictive analytics model, this is what we do, because the first thing is we're going to be defining the problem that we're getting. So with my little story here, I already gave away a lot of stuff. So in this case, we're going to start by defining the problem. So in this case, when we define the problem, we are a bank. We want to know who are we going to be, sending things to. People are going to be either calling these people back or not. Sometimes you might be called into a model and they're asking you to do your predictive analysis, because I went into that case. I worked in finance for many years. And when I was in finance, it became, fancy to say, can you do a predictive modeling to tell us what the finance is going to look like? But in that case, it just didn't need predictive modeling. It just needed forecasting, which is a different one to predictive modeling. Predictive modeling is, like I said, in that case of who goes into bucket 1, who bucket 2, bucket 3, like a human would, but it's doing it automatically. Forecasting is just to say, we have 1 apple today, you have 3 apples, the following day you had another 2 apples the next day. Forecasting is you can never get a 0 apple. We just say, what's the average? And then we run it through. Or we say, maybe your hunger goes by 0.5 apples and we run it for forecasting. Like if you are in finance, forecasting is not predictive modeling. So when you come here, first step, when I say define the problem, this is where you say, this is going to be predictive modeling problem, or it's just going to be a forecasting model problem. All of these issues, what's common about it, about forecasting and predictive modeling, they deal with stuff in the future. So it's either you have some inputs now, but what's going to happen with the model, with the data for the future. So anything else that has to do with are we going to meet our targets this month, which is what salespeople likes to ask. It doesn't need a predictive modeling. But the one, if you're in a call center, to say, how do we classify the leads that are coming through based on the form that they just filled? It could be predictive modeling candidate if the form is live and the action has to happen immediately. If there is no timing issue onto it, they can just do a normal data analysis, wait 7 days and we'll tell you who filled up the form. It doesn't have to go into predictive analysis. I hope I'm just clearing it up to say, just defining the problem is vital state so that you can understand is this going to be predictive modeling or not. If it's not, you move it aside. When we did with big data, that's the first step that we start with. We're just understanding what is your goal? What is the goal of the model? What are the variables that you're going to be working on? It's going to be person's salary, where they stay, their credit scoring, their preference product, which is going to be credit card, home loan, or whatever the case is, and what criteria will make them successful. Maybe it's not just the credit scoring of 45. Maybe it's the credit scoring of 45 plus the income that's greater than 300 rands. So all of those criteria, you build them before you build the model. So if you don't have a criteria, it might just tell you that maybe that is not the good solution for predictive modeling. It might just need data analysis, and you just leave it there. So if you know what are the variables and you know what are the success criteria looking like, then you're in good stead for predictive analysis or to building a predictive model. Okay, so I think number one is quite self-explanatory. It just took me 5 minutes to explain this one side, but it's quite important for us to know that most of the stuff fell off. I've been in finance for over 10 years. We've never done a predictive analytics model. Even though we have the capability of building it, we even tried to hire some data scientists. When they got there, they said, you can't be building predictive modeling. That's just forecasting. So this is quite important. Even if you know how to do it, you might land into a job or into a project where they don't need predictive analytics. The second one is you start to prepare your data. You prepare your data for to start. So this one, half the time, the people in the project already have the data. They can never pull you into a project without the data. If you are quite unfortunate that you are in one of those thumbsuck projects, you will have to define the data that you're going to need. But that you don't have to worry about. Most of the time that I've been involved in, and I know about all the people, even when I was in UJ, we were doing big data, you will be given data itself. You just have to go ahead. If you're starting from scratch, then you have to gather the data, the relevant data, look at the data sources, look at what are the customer needs and address those things. But since you don't have to worry about that one, just go look at the data, look at what the source is, remove the duplicates. You do the normal data cleaning steps. Some of those steps I went a little bit in high level just to say, this is what you do. You remove the duplicates, what in the book. But if you don't have that, you just look at the outliers to say, this data, we're looking at people that are applying, but this one is a recommendation. People that are applying for credit and a recommendation. Recommendation is an outlier, then you take it out. You only look at the people that are recommended. That's just the normal data cleaning steps that you're looking at. Missing values somebody else because the form doesn't force all the fields to be there. There might be missing values that you might have to come up with your own thing to say. If somebody didn't put the agenda, just default it to MS instead of Mr. or Mrs. Something like that. So you can normalize all of that data in that case, just on step number 2. Step number 3, you now start to do your exploration. Exploration of your data. So when you do that exploration, number 1, if you are smart enough, you can actually get, if you're going to do predictive analytics, you can get a data engineer or a data analyst to do the cleanup for you. And then you only get involved on number 3. So you get involved on the problem, you go into the meeting, you define the problem, you hand this over to the team that you are helping, probably the sales, you ask them who's the salesperson there. They give you the salesperson, you tell them to clean up the data, make sure that the data is right, and then you come here to explore the data. So when you get to exploring the data, this is where we're talking about, the last time we spoke about descriptive analytics, which is where you get your data and you say, which is the highest, which is the minimum, which is the average, all of those boring things. That's just describing the data. So you need the descriptive analytics. But now, remember when you come here to exploring the data, you must remember that you are working on data that you know. So you don't have the full data because you don't know who's going to be applying tomorrow. You're working on who applied today. So you take a sample, to build a model, you take a sample of data. Let's say, for instance, our sample will be in a month. Then we say, how many people applied in a month? And you take your sample data, you just run, you go to in your Excel, you can do this even in SQL, just go to data analysis or data descriptives. It shows up and you can go there from analyzing data. You can just say, what are the mean, the highs, the mode, the whatever the case is, you get that. That's called descriptive analytics on the whole data for the month. And then after that, you take a sample, because the whole data for a month, it's a sample because, there's new applications coming in. From that data for a month, you take another small sample. And this small sample, you try to test if it's going to give you what the whole month sample will give you. So you're not just taking a day. This is not a drop down. You can't say, I'm going to take one day and then predict the movement of data for one day if it's going to give me the data for the month. That's the wrong way of doing it. You take from the data of the month, you take random data points from the data for a month. If you're saying if the data for a month is 10,000 records, you're going to say, okay, I'm going to take 10% of it, probably, which is 1,000 records from random days. And you bring it together and that becomes your sample data. When you get to your sample data, you do something called inference statistics, where you're trying to see if that small data can tell you more about the big data, which is a month data. So you look at that one. That's another step. If they ask you and they pull you into a meeting where they are trying to do a predictive analytics, you can just knock them off their socks to say, we're going to have to take a sample of the big data, and then from there, we're going to do random data picks. Those data, people that are smart, they'll tell you what algorithm is being used to take random data points that are not related. And then you go to step number 4 after that. So step number 1, step number 3, you get somebody else who's smart enough from the data team to tell you how they're going to do it. And then you do all of that thing. Step number 4 is something where you start building the model. So you start building a model. So you build a model or you start training the model. So you build a model in this case. So remember, you have month data, and then you have random points within the month, random 1,000 points. So what you do is you start to do different formulas to say, out of this random data that I have, how much of it, if I use this random data, if I use the 1,000 records, how much of the 10,000 records can I predict from the 1,000 records? That's what you do when you train the model. And if you are doing your master's, this is what you do on your paper to say the correlation analysis, your regression modeling, all of those things. That's what you do to predict out of the sample, because all the time when you do your master's, they don't need you to take the whole population. You take a small population, and you said the small population, is the data within the small population, is it captured by one person? There are algorithms or there are formulas that you use for that, or algorithms that you use for that. If it's captured by the same person, will tell you that only December captured this. Entry number 1 is the one that filled up the whole form. If we can see that it's data from different various people, will be able to see that, which is the 1,000 random people. Whether you look at principal, component, whatever the case, it's just telling you the correlation between them. If those things are not related in each way, then we're like, okay, they are not related, meaning they are not influenced, they were not handpicked, they were randomly picked. Then we're like, okay, out of those randomly picked 1,000 entries, how much of those are going to give us if we try to predict the 10,000 records? And then here you'll come with a score in here. And then when you go into stress sessions and people are talking about scoring and they're coming with how much closer to the reality that model is, whether it becomes 90%, 95% confidence level or 99% confidence level. I've seen a model where it goes, they say out of the 1,000 random models, it must give you 99% of the big sample that you give. If it doesn't predict that 99%, they send it back. They keep on making tweaks on it. That's the confidence level. So that 99%, if this issue that we were talking about was for healthcare, so for instance, somebody's about to die, that one will be quite, 99% will be quite nicely. But in this case, because we're just applying for people for debt or whatever the case is, I mean, 95, 80% is still quite good on that case. So this is what, when they say confidence of the model, that's what they're looking at. And then you build in the model. After you build the model on number 5, you test the model, and then your model will give you the big boss on top will tell you that this is a life-threatening project, so we need a 99% confidence level, or we need a 95% confidence level. These amounts are being told by your superior or your client, will tell you that I want you to build a model that will predict exactly like December would predict, or that's 100% confidence level. Or this one we say it might miss 1 or 2 things from December. This one we say is we might miss about 5 things that December would do. That's just the testing, okay? And then after that, the last one that we're looking at is number 6, which is the deploying. When you deploy, this is where you say, okay, we're going live with this model. We're just gonna let it out there, and then it's gonna go live on the records, people that are capturing online. They're gonna come through and it's gonna say approved or not approved, or bucket 1, bucket 2, bucket 3, and the call center people will start calling. Now, when you start to get the false positives and false whatever the case is, it's where a person that's supposed to, say for instance, we are splitting people by gender. So instead of going into bucket 1, we know only males go there. Then we find a female in bucket 1. That's where we know that something is wrong with the model. And then in that case, you can already see what you need to do. After you deploy, you don't celebrate. You just don't say, I won a trophy. And then you celebrate, but you rather go back to exploring the data, or you can go back to number 4, or you can go back to number 5, where you keep on testing your data. So it's a never-ending loop where you can keep on going back once you reach here. But the nice part about it that I like here, that I always say, this is where you do documentation and you do training. Because you already built the model, you already figured out what did you do to get to 95%, to think exactly like human December, to say this one is bucket 1, bucket 2, bucket 3. Your model is already coming to hit those variables. Then once you do that, you document it, and then you start training the people. So I hope I tried to explain a simple big data. How do you build something in big data in a quick, 20, 30 minutes, where you're getting applications that are fast. But the case for it, when you go to problem, number 1 is they are coming faster than the rate that you can sort it manually. And then after that, you ask the team that you're going to be helping to prepare the data, or to help you, get where can you source the data. If you are unfortunate, you're working for a small company, you'll be the one who's preparing the data. and doing all of those. So you need data cleaning techniques. If you need that, I mean, we can always chat about, what do you do to clean up the data, remove duplicates and all of those things, but faster. Then after that, you start to explore your data, what's sitting inside your data, you test your data, and then you deploy. So I've tried to do a high level. I don't know if there's any other questions, just by show of hand, just let me know. Get a question. If you don't have, I mean, I'm always excited that we can do another high level. I mean, I'm trying to explain what took me a whole 6 months to learn in big data in UJ. Half of this, it's got AI, so you have to deploy AI somewhere. I'm trying to do this thing in 30 minutes, so that's quite a challenge in preparation. So how do I do that? But I hope you enjoyed it. We're gonna be back again on Thursday, same time, same link. Please feel free to pop me. If you're on the WhatsApp group, just comment there to say, what other topic would you need clarification or high-level talk on? It doesn't have to be technical. I'm not gonna bring in the numbers itself. I'm just trying to do a high level to say, what does it look like? Just let me know what topic you're interested in, and then I'll be able to cover it, whether it could be this Thursday or the next Thursday. But from here, thank you very much for joining. If you have any other questions, just let me know.